Okay, guys, so in this video, we're going to be talking about sound wave and light wave. These are two very common waves that we have. So one sound wave is a mechanical wave, and then this is called electromagnetic wave, right? We've specified that in the first. So if a sound wave, it need a material or medium for it to travel, and then light wave does not need a material. Right. Okay. So today we're gonna particularly talking about what are depending on these things. Okay. All right. So first one is sound wave. So sound wave, we can use a few words to describe it. So first we can use a volume. Okay. If I talk very loud compared to I talk very quiet, so what's the difference? So say this. If I've got the guitar over here, right? So if I push the button, so if I'm just not push the button, if I'm just like play the string, I have a sound, right? I can lightly play it, or I can move a big distance, play it. And you can see the two sounds sound exactly the same, except the volume is a bit different. Say, let's hear it again. You can see the second volume is much bigger. If the second volume is much bigger, what did I make the difference? The only differences that I made was the amplitude. I had a small amplitude compared I have a big amplitude, right? So the volume is actually dependent on the amplitude of the sound wave. Okay, this is sound wave. Okay, so I'll write here big amplitude. Now will give us big volume. Okay, so that's the first one. All right, the second one we can use to describe sound wave is the pitch. So I can talk with a very low pitch, right? Like this. Or I can talk with a very high pitch. So what's the difference between a high pitch and a low pitch? So the pitch is actually dependent on what we call the frequency. Right? Okay, so if the frequency is really big, the vibration is very, very fast. If it's a fast vibration, a big frequency, the pitch is much higher. If it's a slow and a very slow vibration, the frequency is much lower, then that gives us a much lower pitch. Okay, all right. So say that frequency is so big frequency is high pitch. And then obviously lower frequency, low pitch, okay? And this one, I can show it on the guitar string. So on the guitar, I have a few different string over here. Each string, we can change the speed, okay? So I'm gonna write over here, say this. So the mechanical wave the speed of the wave depends on the medium. Okay, if I can change the medium, I can change the speed. Okay, say here. This is a very thick string, so it goes very slow. Okay, and as the string gets thinner, it actually travels faster. You can hear the pitch is getting higher and higher. Even though the wavelengths are exactly the same, it's from here to here. The wavelengths are exactly the same, but because it becomes thinner and then the pitch gets higher, okay? So let's use the equation to show it. Say V equals to F lambda. If I increase the speed, the wavelengths don't change, then the frequency is increasing as well. Okay, so that's why if I change the string or I make the string more tight, if I make it more tight, this is making it loose. Speed slows down. Frequency becomes small, okay? Now I'm making it tighter, I'm increasing the speed. If I increase the speed, it increases the frequency. Okay, all right. So this is I'm changing the speed, and I can change the frequency. Okay. So another way of changing the pitch is we want to change the frequency. We can go like this. Okay, I'll write over here. Say wavelengths don't change. Increasing speed will give you increasing pitch or increasing frequency. And which will give you a higher pitch. Okay, so that's what we get with guitar over here. Okay, all right. Let's say another situation. Another situation is this one equals to F lambda. Let's say I'm going to keep speed the same. If I want to increase the frequency, speed the same, I must decrease the wavelength. Okay, let's say here. Keep speed. Well, speed is dependent on medium, so I'll say keep the medium the same. Decreasing wavelength will give you an increasing frequency, which will higher pitch. Okay, so you can copy this down. Make sure you copy this down to your notes. The notes I gave you was from like 6 years ago. So I've changed my teaching now, but I haven't rewrite the notes. So these things actually you need to write into your notes. Okay, so make sure you write that into your notes. I'll just quickly adjust the camera a little bit, move it down a little bit. Okay, so make sure you write this down. Okay, all right. So now let's have a look of the situation here. So let's keep the length the same. Let's keep the speed. Change the wavelength. Okay. Let's keep the speed the same. So I'm just gonna play this string. I'm keeping the speed the same. Okay. What I can do is I can decrease the wavelength. Wherever I put my hand, I've decreased the wavelength. Okay. Say the total is the wavelength. If I put it over here, I've decreased the wavelength. You can see now the wavelength decreased, the pitch has increased because the frequency gets higher, and that's because of this situation. Okay, all right. So now you can see volume and pitch with sound wave. That's how it changes the sound wave. Okay, all right. So now let's look at light wave. Oh, by the way, the speed of the sound I mentioned it in the last video, so you can write here. Speed of sound in air, V air equals 330 meter per second. V water is 1,500 meter per second. In metal equals to 5,000 meter per second. You don't need to remember this, so the number will be given to you if you need to calculate it. Okay. And then obviously if air changes, if the water changes, maybe the speed will change as well. Okay, so let's have a look of light wave. Light wave, we have a few words to describe it. The first one is called intensity. Again, same thing as over there. Intensity is kind of measures the amount of energy. We use amplitude. Okay, so over here, the amplitude kind of like boom, big vibration, lots of energy, so it's very bright. Okay, and then the color will be dependent on the frequency. And we've used the other in the other video, I've used thing to calculate. And then speed of light. So the difference between these two is this. I'm gonna write it over here. Speed of light in vacuum. I first write the speed of light in vacuum. So V vacuum equal to 3 times 10 to the power 8 meter per second. If light goes into a medium, it actually slows down. Okay, so I'll write over here. Say sound wave needs a medium to travel. So the more dense the medium, the faster it travels. Okay, so why is that? Let's say we use a domino as an example. Say this is air, okay, compared to, say, metal. Okay, so if sound comes and push this one, it takes a wire then for it to push this one, and then push it this one, and vibrating forward. But if the metal is very tight, it's hold on here together. You push this one, and then bam, this one fall down straight away. This is the reason why sound in air, in metal, travels a lot faster. Okay, so this thing is going up again. Okay, let's move it down a little bit. Okay, but if we look at light wave, it's different. Light wave actually don't need anything, right? If there is a material, if it's very dense, it actually slows it down. Say light wave do not need a medium. A dense medium will slow, I'll say dense medium, give an example. The example will be say glass or plastic. That's what we've actually done before with light, right? The plastic will slow the wave down. Okay, exactly how much does it slow it down? And we actually have equations we can calculate. So, but here you can see that light wave and sound wave are like very different two waves. Okay, all right. So make sure you copy this down into your notes, and all of these are super important. If I bother to make this video and write these things down, so make sure that you copy it down as well. So in your booklet, there were quite a lot of work. So which is on page 19. So if you've got the booklet, that's great. If you don't have the booklet, I've uploaded. So basically, you need to be working on wave properties, the electromagnetic spectrum, and changing wave speed. So these three topics that you guys can do now. So if there's any questions in there you're not too sure of and you want me to talk about it, and I can make another video to talk about it, okay? So, but that will be your homework on page 19, okay? All right, so thanks for watching and have a great day and stay safe. So I'll be uploading more videos in the next couple of days. So any feedback or questions, or just send me an email and I'll help you out, okay? All right, have a good day. See you guys.